So today we're going to start a module on programming in Python for data science. We're going to teach you a bunch of programming tools that'll help you apply the concepts you're learning here and do interesting data analysis. So first, a few announcements. Office hours start this week. We'd love to see you in office hours. We have both in-person office hours during the day and we have online office hours in the evening. You can find details on the course webpage. Tutoring section signups will be released tomorrow. Let me tell you a little bit about tutoring. We have a small group tutoring as an option for those who would like more practice or more help in the course. Not required. The format is small groups, usually 4 to 5 students, led by a tutor, meeting 1 hour a week. And each week you'll do a worksheet with some extra practice and you'll have a member of course staff there to help out as you work through them together. So if you do sign up, we ask that you commit to attending the tutoring section weekly until the midterm. We have a limited number of spaces, so we'd prefer to keep those for folks who are going to show up. But if you feel like you're struggling in the course or you just benefit from having extra help, we would love to see you in tutoring section. Homework 1 was released on Friday night, as homeworks always will be, and it's due this Thursday. So if you haven't got started, you might want to get started. If you submit by Wednesday, you get 5 bonus points. I saw a question about participation credits and do you need to write in the chat to get participation credit? You don't need to write in the chat to get participation credit. What I would prefer is that you ask questions that you have in the Q&A part. You're also welcome to comment in the chat. We might not be following that as closely for questions. Professor Ani prefers if you limit use of chat. When I'm lecturing, I'm fine if you want to use chat, as long as you keep it relevant and appropriate. All right, so what we're doing this week, we're going to start teaching you about Python programming and specifically programming intended for the data science work we're going to do. Today we'll look at the primer on the Python programming language. Then on Wednesday, we'll start to look at different kinds of data you can represent in Python. And on Friday, we'll look at operations you can do on tables of data. All right, so let's start with Python. Python is a programming language, a way of writing code for the computer, and it's the most popular one for data science. And also a very popular language for general software development. If you're an engineer who's building software, Python is one of the common tools. So we're going to teach you how to use Python. You're not going to be an expert on all of Python, but there is some core Python fundamentals that we're going to teach you about so you can become productive with Python for data science. So for this course, you'll need to be able to do a little bit of Python programming. If you've never done any programming before, that's totally fine. We're going to get you up to speed from nothing. In programming, learning to program is kind of like learning to ride a bike. So you learn by doing, by practice, not by watching me, sadly. So we're going to give you a bunch of practice. And as you do that, I want you to be gentle and kind to yourself. Everyone who learns programming goes through experiences where we get stuck. It doesn't work quite right. It can't figure out why the darn thing won't do what I want. And even expert software developers routinely go through this. It's called debugging. I wrote the code. It looks great. It should do what I want, but it doesn't. So just be patient with yourself when that happens. It happens to all of us. If you get stuck, Ask for help, come to office hours, post on Ed. We'd be glad to help you get unstuck and teach you some tips for what to do to figure out the source of the problem in the future. One of the most common sources of the problem is that computers do what we tell them to do, not what we want, and they're really literal and persnickety. And we have to specify what we want them to do in great detail. And it's really common for us to tell them to do something that we later realize isn't quite what we wanted. You can follow along. I'm going to show you a bunch of demos. I'm going to show you Python by example. So follow along if you want. Go to the course webpage and click on demos next to today's lecture. So let's start. Let's do our first one. I see that I need to share a little differently. Sorry about the delay. All right, let's try this. Hopefully you can see this. All right, so here's a notebook. And all the notebooks we give you are going to start with this cell at the top that you have to run. Don't worry too much about what's up there. That's a bunch of Python code to get everything loaded so that it's set up to work with data science and with the Python libraries we're going to use. All right, so let me give you a demo. You can use Python as a basic calculator, as I showed you in the first lecture. So we can write, these are called expressions, where we work, for instance, with numbers. Whoops, that wasn't what I wanted to do. Let's just delete that cell. And you can do all the basic operations that you're used to. For instance, you can multiply, you can divide. You can also combine these operations and write a more complicated expression. Now, something interesting happened here. You'll
Professor
notice,
Wagner, may I interrupt for 1 second?
Please do. There
is a comment that says there are too many people on the server to follow along with the demo. What would you advise?
Oh, no. Professor Ani, maybe you could ping our support staff in the Jupyter Slack, and to all the students, perhaps you could try again in about 5 minutes. Our Jupyter installation, when it runs out of resources, my understanding is that there is an automatic process to try to spin up more servers, but it could take a little time. So maybe give it 3 to 5 minutes and see if it's still causing problems in 3 to 5 minutes. You all are guinea pigs for our Jupyter installation. I'm not sure there's anywhere in the world that has 1,500 people using Jupyter at the same time. You can also try this at home after the lecture. All right, so I typed in 2 + 3 × 9. And I got 29. Does that look right to you? I would have expected 2 + 3 is 5 × 9, 45. Oh, wait. Well, that's not quite how the computer interprets it. The computer interprets this as 3 × 9. It does the 3 × 9 first and then adds 2. So it gets 27 and then adds 2 to that. So if that wasn't quite what I wanted, here's how you fix it. You add parentheses to indicate multiply, add 2 + 3 first, and then multiply by 9. Okay, so we got 45 if we do that. So you can make up complicated expressions, putting parentheses to indicate which operation should be done first. Now, if you wanted to multiply 2 times itself a bunch of times, you can do 2 × 2 × 2 × 2, or you can use an exponentiation operator. So the ** says raise to the power or do exponentiation. Finally, numbers are one kind of data, but another kind of data in Python is text, and we'll work a lot with text. And so in Python, that's represented as something called a string. And the way you indicate to Python that something is a string, that it's text, is that you put it inside quotation marks. All right, so there is a piece of data that is text. And you'll see I put it inside this single quotation marks. You can actually use double quotation marks too. That's an alternative way that's totally equivalent. Python slightly prefers single quotes, so that's usually what we'll use, but you can use whichever you prefer. The purpose of the quotation marks is to indicate to Python that this is text. Let's look at what happened if I didn't type the quotation marks. Oh no, error. I got an error message. So Python tried to run this cell and it said, I don't know what that means. And I'll tell you in a moment why we get this error message. But Python basically doesn't know how to interpret this, and we need to give Python an indicator that this is text, not code. Python tried to interpret this as some Python code and said, that doesn't make any sense as Python code. That's not valid Python code. So we got to tell Python, this is not code, this is some text. And the way we tell it that is by putting in quotation marks. All right. Let me pause for questions here. Professor Ani, are there any that seem particularly valuable to focus on?
There are a bunch of questions as to why you don't have to type print to make stuff show, but other than that, so.
Great. Well, we don't have to type print because the notebook will automatically show the result of any code that gets run. And the result of something like 3 + 7 is the number 10. So the Jupyter Notebook spares you from having to type print.
There's a lot of questions about why do we have both? Why do we have double quotes and single quotes? What if we want to print the double quotes?
Yeah, there's really no need to have, it's not really that essential to have both, but it's kind of handy to have both. So one way that it can be handy to have both is if you want to have some text that has a quote in it, like something like this, but I want this to be text. If I tried to put this in single quotes, I would have a problem. Python would say, oh no, you've got, the text is can, and then after that, it starts interpreting the rest as code. But then the rest of it doesn't make any sense as code. So instead, what you could do is you could use double quotes for that. And now Python knows you started with the double quote, so you'll end with a double quote, and it doesn't get tripped up by this single quote here. All right, let me go on. I'm going to see if I can get my screen sharing to work here. Screen sharing is not cooperating with me right now. There we go. All right, names. Names are a way to refer to the results of past things that we computed. All right. And we to create a name, we use an assignment statement, what's called an assignment statement. So if you see a statement that looks something like this with an equal sign in it, that's called an assignment statement. And what assignment statements do is they create a name and they associate it with the result of some computation you did. So in this case, it's creating the name hours underscore per underscore week. And then it's associating with that name or assigning to that name a number. And the number is the result of computing 24 times 7. So don't get confused by this statement. The equal sign is not indicating some kind of mathematical formula. If the right-hand side of an assignment statement, if the value of that changed in the future, the name wouldn't be automatically updated. This is indicating, it's like we're making a note. It's like writing down a Post-it and saying the name is hours per week, and then I'm writing down a number that's associated with that name. And that will be remembered for the future. And in the future, any place where you use this name, Python will remember the number that was previously associated with it. Okay, so this is called assignment. The left-hand side, the part before the equals side, is the name that gets assigned to. And the right-hand side is the, well, it can be any expression. Any of these techniques we used before, and it gets evaluated, and the result of that is what gets associated with the name. These assignment statements don't have a result. They make a note, okay, I'll remember hours per week is associated with this number, but they don't produce a value. So if you run them in your notebook, you won't see any output under the cell because they didn't yield any output. They didn't produce any value. An assignment statement changes what's associated with the name. If I were to later execute another assignment statement that said hours per week equals 53, it would be like going to that Post-it note and crossing out the old value and associating it now with 53. So it changes what the name is associated with if the name already exists. Okay. So now let's do a demo of this. All right, so let's create some names. For instance, here I'm creating a name called A. I associate it with the value 4. If I then enter in the name A, Python remembered that I associate with 4 and says the result of that is 4. It looks up that name in its memory bank and remembers that it was associated with 4. And I can create multiple names and it'll remember all of them. I can use expressions with names like this. And in this expression, first it looks up the value of A, the value associated with A, and it plugs that in. It says that was 4, and then it multiplies 4 times 3. So this is a little bit like mathematics that you might be familiar with. You can do any expression you want. And when you have an assignment statement, the right-hand side can be any expression you want. So what will this associate? What value will get associated with the name total when I run this? Four plus 9, 13. Yeah, because A is 4, that gets plugged in. B is 9, that gets plugged in. So this turns into 4 plus 9. Python evaluates 4 plus 9, says that's 13, and then says, okay, I know I better associate 13 with total. Now notice when I did that, there's no output under this cell because this statement doesn't return a value. But if I asked Python to show me the value associated with total, you can see it remembered it was 13. Okay, so why do we say A is 4? It's because we assigned A equals 4. We assigned B equals 9. And then later when we used A and B, that use the values 4 and 9 associated with them. Now, if you have an existing name, you can do an assignment to it again. A was 9, but maybe I decided I didn't want A to be 9. Well, I can do another assignment statement, and that will change the value that's associated with A. It's kind of like crossing out the old value and overwriting it with new value. So now, if I look at the value of A, now A is associated with 42, not 4. So any future uses of A will use 42. For instance, if I wrote A plus B, B was 9, A is 42, so I should get 51 here. And I did. I got 51. All right, fine. That's all good. Now, take a look at how I define total. I define total with this assignment statement up here. Total equals A plus B. What happens after I change the value of A? Do you think I should get 13 or 51? Well, let's see. Sure enough, 13, because total has already been associated with the value 13. And that's still true. I didn't reassign to total. So total is still, Python still has 13 in its memory bank for total. Even though I changed A, Python doesn't go back and rerun this assignment statement. That was already done, and it's not happening again automatically. So if you wanted to update the value of total, you would need to reassign to total. And now the value of total would be updated. You can see that if I assign to a variable multiple times, it can get a little confusing because there was the old value and there's the new value. This can get you in trouble. For instance, if you type A right here, you get 42. Now up here, A was 4. But if I rerun this cell, look out, 42, because now A is 42. So Python is running them in the order you click run, which isn't necessarily the order they appear in the notebook. So if I ran them out of order and then I showed this notebook to someone else, they might be totally mystified. It might be very confusing because they say, look, A was assigned to 4, it should be 4, and then here we printed the value of A and it's not 4. What happened? So if you find yourself running cells out of order, this can cause problems if you've assigned to a value multiple times. So if you ever have this problem, what could you do? What could you do to kind of reset yourself and get yourself back to an okay situation? Yeah, rerun them in order. Rerun them in order. Absolutely. That's great. And one thing that's really handy in a lot of cases is if you go to this kernel menu up here, you can do restart and run all. Restart is kind of like a reboot of your Python notebook. It saves all the stuff you've typed in, but it clears the outputs. And then run all will run each of the cells one by one from the top. So you don't have to do it one by one manually. Or you could do it manually. You could restart, clear all the outputs. That clears out all of Python's memory and everything. And then you have to run the cells, and you could run them by hand one by one. All right, our servers. There we go. My computer's slow, but I could run them one by one and you'd see, okay, we could go down here, we could run them, and it's tedious, but you can do it. We just keep going, we go. Every single one until we're bored beyond tears. And oh, look, now we're back to a clean state where A is printing out 4 here because we've only assigned A to 4. Okay. And yes, you can do keyboard shortcuts. Control Enter will run the cell, so I don't have to mouse over to find the button to click. Okay. Now, one more point. I want to make the difference, indicate to you why we have quotation marks. If I type in total, that's a name, that's referring to the name total, and Python will show me the value of total. But if I put it in quotes, then this is text, it's no longer the name. And so now Python treats that as a string, as text. Okay, so you can see the quotes tell Python, don't interpret this as code or as a name, interpret this as text. Let me pause now for questions. The reason we have quotes is to indicate to Python that something is a string, is text. If we didn't put that in quotes, then Python, anything we typed, Python would try to interpret that as code. Probably means it would try to interpret what you typed as a name. And if that name didn't already exist, it'd give you an error. And if the name did exist, it wouldn't be what you wanted.
Professor Wagner, there's a very interesting question about, are Jupyter notebooks used only for data science?
Are Jupyter notebooks used only for data science? No. They're really popular for data science, but they're also popular in a bunch of areas of science. Used to be that we got told we had a lab notebook, and every experiment you did, you wrote down in your notebook, here's the experiment I did, and here's the data I collected, and here's the analysis I did. Jupyter notebooks are becoming very popular for science, for instance, because you can have the equivalent of a lab notebook where you collect some data, but then you also do your data analysis in the notebook. And if you go back and you collect extra data, then you can go revise that and rerun your analysis and see how that changes your conclusions. Now, that's just one example. We use them in my group for our research to facilitate trying out different things. So Jupyter notebooks are widely used in computing. We're not going to use pandas or Node.js in this class. If you know what those are, if you don't know what those are, you don't have to worry about it. We're going to use a library that was designed specifically for this class called the Data Science Library. That's very similar to tools that are used in industry, but has been simplified a little bit to make it easier for you for the first-time programmer, and let us focus on the data science concepts without getting too caught up in the nitty-gritty of the Python coding stuff. All right, let me continue on from here. I want to talk a little bit about functions. Functions are a way to do some more complicated computation, and we will give you libraries that contain built-in functions. So they'll do stuff that you might want to do. It's code that's already been written for you. You don't have to write it. Now, if you see some code, Python code that looks something like this, f parenthesis 27 close parenthesis, that's called a function call. It's invoking a function. It's invoking some code. This code is called a function. And in this case, the name of that function is f. So it's saying and telling Python, please invoke the function with the name f. And invoke means run that code that someone else wrote. And when you run that code, I want you to give it the number 27, and it's going to do something with that number 27. Okay, so if you see code that looks like this, you'll know before the parentheses, that's the name of the function. Inside the parentheses, between the parentheses, that's called the argument to the function. That's the thing that the function is operating on, the data that the function is working with. Okay, so in coding, argument doesn't mean a debate. It means the data we're going to work with for the computation. You might see this pronounced as call f on 27. So here is an example of another function call. In this case, The name of the function, you can find that's to the left of the parentheses. So the name of the function is max. That's provided by the folks who built the Python programming language. What this function does is it accepts two numbers and it figures out which one is larger, and then it uses that one. The result of this function call is the larger of the two numbers. And you can see here, we're asking it to operate on two numbers, the numbers 15 and 27. So in this case, there are actually two arguments. There's the number 15 and there's the number 27. And the arguments are separated by a comma. So if you have multiple pieces of data that are needed for this function, they can be passed in using a comma. All right, let's do a little demo here. Oh, yeah, I wanted to talk a little bit about why we have names. Well, I'll come back to that. One example function that we have is the absolute value function. That will take a number and convert it to be positive. All right, so here we gave it the number -5, and the result was it said that's negative, I'm going to convert that to be positive, and made it 5. You could, if you'd given it the number 5, it would have said that's already positive, it's going to return the same number you gave it. Now you can, the data you give it, the number you give it, can be the result of any computation you might want to do. You can use any expression. So for instance, if I type this, I'm going to run the function apps. I'm going to call the function apps, and I'm going to give it some data. What data I'm going to give it is a number, and the number is obtained. Python is going to evaluate this expression 1 minus 3. So what Python's going to do is first, it's going to figure out what is 1 minus 3. In other words, -2. And then it's going to call apps on -3, and apps converts that -3 on -2. 1 minus 3 is -2. We're going to call apps on -2, and then apps is going to convert that to be positive, and it's giving us the result 2. So for instance, if the daytime temperature for today, the daytime high was 76, and if the nighttime low was 51, then the difference between the daytime high and the nighttime low could be obtained by subtracting the two and then computing the absolute value. Now you see here, I assigned a name to the daytime temperature. I assigned a name to the nighttime temperature. And then I called apps on an expression that was the difference of those two names. So Python will first evaluate this expression to figure out what to pass to the apps function. In this case, the difference was 25, and then pass 25 to apps, and apps gives me 25. And if I had computed the difference the other way, then apps would have been called on -25, and then it would have converted that to a positive number. The other thing to notice that I did here was I put multiple lines of Python code in the same cell. You can do that. You just separate them, each line of code on its own line, and the Jupyter will run all of them, and then it will show you the result of the last one. It doesn't show you the result of any of the previous ones. What's the difference between a parameter and an argument? Basically, for purposes of this class, you consider them synonyms. You can think of those as two words for the same thing. We could make a little bit of a distinction, but don't worry about it right now. Could I demo the F27 example? Sure, let's try it. One of the great things is anytime you are not sure what something's going to do, you can just try it in your notebook and see. If I run that, what happens? I get an error message. I get an error message. So let me teach you how to interpret error messages, because you might get this when you're writing code yourself. The way you interpret an error message, it might be a very long thing, is like the way you read a mystery novel. You start at the end, go to the very last line, look what that very last line says. And this is the type of error, that message that Python is giving me. It says name error. That's the type of error. And then an explanation, name f is not defined. So what this is telling me is there is no function named f that has been previously defined. Python defines the names of some functions like max and min and abs that exist already for you, but there isn't one called f. So Python said, sorry, I don't know any function named f. I can't help you. I can't do that. And it gave me an error message. And the other thing you can look at when you have error messages is you can look up above this. There'll be some code showing here and an arrow pointing to one line of code in particular. And that was the line of code that was causing the problem. In this case, there's only one line of code in the cell, so it's obvious which line was causing the problem. But if there were multiple lines of code, the arrow would show you which line caused the problem. Okay, so let's do a few examples of some functions. Just some simple examples here. If I did min like this, that's calling the function min, and this time passing it 2 arguments. The numbers 14 and 15, and 14 was the smaller of those, so that's what it returned. Another function that exists is called the round function. The round function takes a number that might have decimals in it and rounds it to an integer. Now you can see that it's rounding it to the nearest integer. Sometimes we don't want to round to an integer. We just want to round to a certain amount of precision. So the round function that's defined by the Python actually allows you to optionally specify a second argument. And if you specify the second argument, that's how many digits after the decimal point it should be rounded to. So in this case, it rounds to the nearest number with 1 digit after the decimal point. So some functions accept optional arguments that you don't have to specify. In this case, that optional argument, the number of digits after the decimal point, kind of has a default value of it's kind of like it has a, well, okay. It's kind of like the default would be to say, I don't want any digits after the decimal point. You could give a different number there. You could say I want 2 digits after the decimal point by passing the argument 2. Another aspect of function calls is that some functions allow you to specify additional information by what's called a named argument. So this is a little bit of minutia. Looking at this code up here, it might be hard to remember what that 1 indicates if you've forgotten how the round function works. So Python allows what's called named arguments. And those arguments are specified by writing something like this. In this case, there's a named argument, n digits. And it might look like an assignment statement, but what it's actually doing is it's saying, I have an argument for you, 123.456. And then I've got another one for the argument named n digit. And for that one, the value is 1. And n digit specifies the number of digits after the decimal point. So that's kind of handy if you're writing code to make it easier for yourself when you come back to it to remember what the heck was this code trying to do. Okay, I want to also show you, I'm going to go back up and show you something I forgot. I want to show you why we have names. I want to show you one common use for names. Suppose I wanted to compute, I figured the minimum wage, and I wanted to compute how much, what annual income that corresponds to. Well, I could do this as a calculation. I could take a minimum wage of $14 an hour. Is that still the right number? Multiply that by 40 hours a week, get an hourly wages of $560 a week for minimum wage workers. Or if I want that annually, there's, let's see, 52 weeks in a year times 40 hours in a week times $14 per hour. And I'd find that a minimum wage corresponds to an annual wage of $29,000 for a full-time worker. But if I wrote this in my notebook, and then 3 weeks later, I came back to look at this notebook, and I saw a cell that had this expression there, I might not know what was the logic. Where is that coming from? What does that represent? What's the meaning of that? How should I interpret that? So it can often be helpful to give a name to these values that helps you remember the purpose for this computation. And this will be helpful for you even when you're not coming back to the code later, but when you're looking at the code just now, because it helps you identify what each of these values represent and what role they play, and that's going to make it easier to think clearly about the computation you're doing. So here's an alternative way that I could have done this computation. I could have created names for each of these numbers. I could have a name for the hourly minimum wage in California, created another name for the number of hours per week, and another name for the number of weeks per year. Then, if I wanted to get the weekly wage, well, if I wanted to get, I guess, the annual wage, I could figure out how many hours are in a year and assign that a name. We can look at what that is. Oh, look, there's a bit over 2,000 hours per year in a full-time job. And then I could compute things like the weekly wages is the hours per week times the hourly minimum wage. And now I know the weekly wages is $560 an hour. Or I could compute the annual wage by yearly wages is, well, the hours per year times the minimum wage. Now, typing all this out gets a little tedious. So here, let me show you something handy about Jupyter. It has, well, there, it has autocomplete. So if I start typing and then I press tab, it will try to automatically figure out what I might have been starting to type and complete what I typed. So in this case, it's thinking, oh, maybe you meant CA hourly minimum wage. That's one of the names I know that starts with CA. And so I can select that and save myself the typing. Well, I didn't do that quite right. Let's try again. There. So now I can compute the yearly wages that way, and this way I get 29,000. And so what you can see here is that maybe it's a little easier to understand the logic behind where I got this value. The annual wage is the number of hours per year times the hourly wage, and where did I get each of those? Well, I can look at how those were assigned to see the logic for how each of those was computed. So maybe this would be easier for others to understand your code and for yourself to understand your code, and understanding your own code is good because that will help you make sure that you're computing the right thing and using the right formulas. Let me take a brief pause here.
Professor Wagner, there's an interesting set of questions that are quite general, which is, how do you know what functions exist? And how do you know what arguments there are in a function?
Great. How do you know what functions exist? We're going to teach you about a bunch of functions, and we'll give you some reference sheets that show you a quick list of all the functions that we taught you about. There are a bunch that exist in Python. There are also people who've written libraries. They wrote functions for you that you can use. The other way you can find out functions that exist is by searching on the web. If you search on the web for Python and how to do something, if there's a way to do it with some existing library or function, you may find an answer that tells you how to do that. For instance, stackoverflow.com is great. But you don't need to do that for this class. We'll teach you all the functions that you need to know. What was the second part of that?
The second part is, how do you know what arguments you can use?
How do you know what arguments you can use? Excellent. Yes. Okay. You can look up the documentation for a function and it will tell you. We have a short summary in our reference. So let me show you how to find our reference. Or if you well, that's not working. So let me show you how to find our reference. If you look up our web page, we will have some resources that have a reference that show you, for a bunch of functions we're going to teach you about, what it does and what the arguments are. For instance, you can find here something about max and the chapter in the textbook where this is introduced. You can find here abs. It says abs of num. So that tells you that it takes a number and it computes the absolute value of that number. Professor Adhikari, anything you want to add to that?
That sounds very good. There's a number of questions anticipating what we're going to do. How do I define my own function? And can I change an existing function? Like, can I define abs to be something else? So there's both the can I, and then there's the recommended practice.
We'll teach you how to define your own function in a little while, but for now, we just want to get you some basics of Python. So hold off on that for another week or two. Can you change an existing function? Don't do that. That's going to cause confusion. So no, you don't want to do that. All right, last thing I want to introduce briefly in the last 2 minutes of class is tables. We're going to organize the data in this class into table. This is one of the fundamental ways that data is presented. And you can think of a table as a lot like a spreadsheet. So it's a grid. It's got a bunch of columns, and each column has a label. It has a bunch of rows. Each row represents one individual, like one person or one entity or one company or one country or something like that. Each column represents an attribute of those individuals. So for instance, here is an example table. You can see this is a grid, has a bunch of rows and a bunch of columns. We put a little bit of data in each cell in this table. Each row corresponds to a state of the United States. Each column corresponds to some attribute of that state. Like the first column is the name of the state. The second column is the short two